It's the sound. I always have my audio turned off. It's the sound that the recording software makes when it starts. It sounds like somebody's loading a pistol. That's what you want to hear in a classroom.
Oh man, that's such a soft subject.
I mean, that stuff happens. That's happened like a lot in the last couple of years, hasn't it?
There's like this past mobility, like you connect the green box. House is Wi-Fi.
Yeah, it's bad. Okay, so what were we doing at the end last time?
Gonna write lambda for apply expression.
Oh, that's right. Lambda for apply expression. Okay, so as of right now, we only go up to a math expression, right? And I think at the end of class, I asked some question along the lines of, can a app expression exist without a lambda? And I asked something along those lines. So if we think about our parse Simon, which produces Basel code for us, right? These, well, I say these last two, but the lambda right here, that guy, and the app expression right there. The app expression can't actually exist without a lambda existing. Does that make sense? Because in an app expression is a list containing an expression followed by 0 or more expressions. And those additional expressions after the first are actually the parameters that are getting sent into a lambda. So I think the way we kind of exemplified this, if you will, is if I say I want to create a list out of A, B, C, like that, I'm calling a function named list. And function list takes in this case, it appears to take in 3 parameters. Okay? This is actually something called streams, where they're infinite streams. So scheme supports taking in an infinite number of parameters. Sorry. Out of the corner of my eye, I saw somebody ask, can so-and-so know your password?
No.
I just responded and said, yep. What's up? Oh, it's Uffenbeck. Uffenbeck needs my password. Which is funny. That is my password. What was I talking about? Oh, so in any case, this might be an example down here where we have a lambda expression that we've named a list. That is, somebody sometime created a define list to be a lambda that takes in this case, A, B, C, whatever, a couple parameters. And what does it do? It conses A onto the cons of B, onto the cons of C, onto the empty list. That's what that guy does in this little example. Does that make sense? So if I want to not have this break and I want to call this blah, I'll call my function blah. So what is blah? Blah is a variable whose value is a lambda expression. And what am I doing with that lambda expression? I am using it inside of an app expression. That is, the lambda expression comes first, or the variable that boils down to a lambda expression, and then the parameters are the rest. Does that make sense? But we technically could have a lambda expression that takes no parameters, couldn't we? So I could have another one, and let me get that higher up on the screen. So I can have define blah 2. Where's Jake? Sorry, coastline. All right, so define blah 2. This guy could be a lambda that takes no parameters and I don't know, boils down to 8 or something like that. It's a completely useless function. It's a placeholder for an 8. Okay, so with that in mind, I could have an app expression, blah 2, sorry, like that. So here's 2 examples of app expressions. The first one has the lambda first, followed by 3 parameters, because that guy expects 3 parameters. The second guy has the lambda followed by nothing else, because he expects no parameters. That make sense? Okay, so getting back to the question I asked last class, where can an app expression exist without a lambda? Maybe the better way of asking it is, can an app expression be applied without being able to apply a lambda? The answer to that is no. The first element of any app expression is, in fact, a lambda. Does that make sense? It's a function. All right, so in order to process our app expressions, which is the last piece of our assignment, assuming we ignore ifs for right now, because we're kind of out of time for dealing with Booleans. So if we just decide our complete language is going to get rid of if expressions, can't ask questions in this language. Deal. You'll probably get it wrong anyways. So in order to make our app expression work, we need to have lambdas working. So what does it mean to process a lambda? So let's just say that we have a lambda that looks like this. Let me steal this code. So let's say that's my Simon code, Simon syntax. And let's just deal with it at this level for a second. So what does it mean to process a lambda? Obviously, we're going to parse this into some Bazel code, but in the generalistic sense, and here I'm going to replace this A for a second. Oh, come on. With a 1. Well, I got to see what this guy's yelling about. We just randomly decided that I'm restoring this thing. And it just randomly decided that, oh, okay, I waited long enough for iTunes. I'm just going to restart KK things. I know. It does sound like Apple. Okay, so assuming we're kind of going through this as human beings and deciding what does it mean to process this lambda expression. What does it mean? When I say x plus 1 here, this is a math expression, correct? Where do I get x from? The variable environment that was extended, that had a scope added to it. What scope? The scope created by getting that guy and associating it with his value. Okay? What's x's value? We don't know. When does x get a value? When does x inside of a lambda get a value? And how do I use the function? With an app expression. Isn't that what an app expression does? If this guy right here is an app expression and blah is a lambda, doesn't me giving A, B, and C as parameters give the 3 inputs A, B, and C values? A is equal to the character A, B is equal to character B, C is equal to character C by my inputs here. Similarly, if I define blah 3 to be that guy, and I say blah 3, 5, that's going to boil down to a 6, correct? Why? Because 5 comes in and we associate x with 5, which does what? It means we're going to add a scope to our environment. What scope? The scope that is x5, like that. Does that make sense? So let's break this down into individual pieces. If that is my Simon code, and let's actually, why don't we define SE8 to be that. So I can say SE8, and then I can say parse Simon SE8 and get the Bazel code equivalent of it. Here's my Simon code, and here's my SE8 parsed. Okay? Because our apply expression on something that has, oh, that's actually unrelated. That's fine. I was wondering where the false came from. Not a big deal. Unrelated to what we're doing right now. So the Bazel code version of this is this guy right here. That is, it's a list that is an app expression. The first element of the app expression is a what? A lambda expression. The second element is a what? A lit expression. Now ultimately, to process this, what am I going to be doing? I need to take this lit expression that holds a 5, and I need to merge that with this parameter list that holds a variable name and create a scope. So to simplify that, if I have a parameter list that looks like that, and I have a list of inputs that looks like that, I need to create a scope that looks like that. Make sense? Do you understand the micro problem we have to solve here? Okay, so I just tried to get it down to the core baby steps. I can't give myself, Matt said we need an environment. We need a variable environment that gets created from this lambda, but I need to merge that lambda, the variable environment that gets started from that lambda, I need to merge that with the values that are coming in from the app expression. Can a lambda be evaluated on its own? So if I have something that looks like this, and I just say, actually, hold on. If I have something that looks just like that, and I ask you, what's the answer? Just what I have highlighted there. It's not even possible to evaluate that, right? The answer is it depends. It depends on what x is. So you cannot evaluate, you cannot apply a lambda directly. You can only apply a lambda in terms of an app expression. Make sense? All right, so we need to write a little function that takes in two lists, a parameter list and a list of corresponding values. They should be the exact same length. So if I had a parameter list that took x, y, z, I should have a value list that took in 5, 7, 13, something like that. Does that make sense? I need to merge them together into a scope. So I'm going to define merge scope to be a lambda that takes in a list of vars, lubs, and a list of values. Uh-oh. Vars, vals. There we go. List of vars and list of vals. I would have had two loves, and that's just not biblical. Ish. I guess if you're a Mormon.
You're solid.
Mm-hmm. Yeah, but he had all the gold. Wealth throws it all out the window. I think that's a point. I got like a 13 now or something. Isn't that the last day of finals week? Is Friday the 13th?
Yeah.
Isn't that terrible? How many of you have a final next Friday?
I got out of it.
Now, really, shouldn't any teacher that has a final on Friday the 13th just either move it or just let you out of it? Do you know what that's from? Do you know why Friday the 13th is considered to be a bad? You know the story behind that? Be an interesting quiz, you know? Baker?
I don't know.
Not in the old Greek or something? Nobody knows?
It wasn't Freddy Krueger, was it?
Oh, that's a movie? I just want you to know that Freddy Krueger is a character in a movie. And that's Nightmare on Elm Street. Jason is the Friday the 13th guy. But, you know, they had to have like a reason for calling it Friday the 13th and having a negative connotation before the movie Friday the 13th came out. It came from, it deals with the church. The Knights Templar. How many of you have heard of the Knights Templar? Okay, Knights Templar are kind of a religious, but a religiously inclined police force. Let's say something along those lines. I don't know what year, way back, 1300, something like that, a long time ago. And they held, so, you know, the conspiracy theorists say that they had some sort of biblical relic or something like that that the Catholic Church didn't want people to know about, you know, whatever. You know, that's all conspiracy theory stuff. But for some reason, the Catholic Church and the Knights Templar held a lot of power over the Catholic Church for whatever reason. Well, on a certain Friday the 13th, Friday the 13th day of the month, the Pope ordered a simultaneous attack on the Knights Templar, taking them all down at once, basically arresting them and torturing them or whatever they did. Yeah. Well, but I mean, you know, keep in mind that's a human organization. So I mean, you know, fine. There's the religious side of Catholicism, but then you also have this organization, and you know, so don't blame it on the Catholics. It was the human organization, and the Pope ordered this attack or whatever, and took out the Knights Templar all in one fell swoop. And that day since has been referred to as Friday the 13th. You know, and having a negative connotation. Isn't that kind of interesting? Yeah.
Wikipedia says that explanation was created in 2003 novel, The Da Vinci Code, and is not historically.
No, that's not true.
Huh.
I knew that way before the Da Vinci Code.
That's what Wikipedia says. You can't argue.
Possibly. Does it have an alternate explanation?
Snopes. October 13th, 1307.
I'm pretty sure that there's a factual basis. I mean, it's possible the Da Vinci Code created the thing. You know, I kind of skipped over this idea that there's some conspiracy theory aspect to it. You know, I think the Da Vinci Code plays out that, you know, what they had was maybe the body of Mary Magdalene or something like that. That was the treasure that the Knights Templar had that gave them power over the Catholic Church or whatever.
Snopes.com says that it's a modern day invention.
I don't know.
It's not.
I will allow that to be possible. But I've known this for quite a while, way before Da Vinci Code came out. So whoever I learned it from, or whenever I learned it, was before the book Da Vinci Code existed. So I think that there is a my feeling is that it is factual that on a Friday the 13th, a real group, Knights Templar, which did exist, was taken down or something like that.
Arrested by the agents of King Philip.
Okay, so is the idea that the order came from the King of England, not the Catholic Church?
Right.
King of France? Okay.
They're talking about torture now.
So it's possible the Da Vinci Code took it a step further and said maybe the Pope ordered
Yeah, he did.
the King of France to do this or something. But whatever, I mean, the story I gave is fairly accurate. Go ahead.
Now, I actually do remember on the History Channel now when they were doing some special on the Knights Templar. I remember I didn't know that it was Friday the 13th, but I do remember them being taken. It said they were taken out on the same day.
Mm-hmm.
Yeah, this is Friday, October 13th, 1507.
So most of what I said is, I think, accurate. It's possible that it didn't come from the Pope; it came from a king or something.
French.
Yeah, whatever.
At that time, I think that was when there were actually two popes. For a while, there was a pope in France and a pope in Italy.
Okay.
I think that might have been that time. Not sure though.
Yeah. But regardless, for computer science class, I think the explanation is close enough.
Fair enough.
So, I mean, the story's mostly legit what I said, regardless of the extra.
I'm sorry I disputed you, sir.
Well, no. I mean, it's interesting. We're always looking for the real thing. But I did know about this way before Da Vinci Code. So I was pretty confident that there was a large portion of truth in my explanation.
Maybe Michael Moore heard you tell this story one time, and that's how we made that movie.
Michael Moore.
No, he's not.
Tom Hanks is in the movie's Da Vinci Code.
Who wrote the book?
Dan Brown wrote the book.
Dan Brown. Michael Moore produced it. He's somewhere in there.
I don't.
Ron Howard. Something.
Yeah, Ron Howard made the movies, but I don't think Michael.
Right.
I can't imagine Tom Hanks acting in a Michael Moore movie.
Snopes.com says that Michael Noms.
And even though I don't know that to be a factual truth, I feel pretty strongly that I don't think Tom Hanks would be in a Michael Moore movie. I think there's quite a bit of truth in there. Michael Moore is the Bowling for Columbine guy. He incites quite a bit of. That's what you're talking about, right?
I don't know what I'm talking about, I guess.
They did make one funny movie called Canadian Bacon.
Oh, sure, with John Candy in it.
I didn't know it was Michael Moore until recently.
Okay, so, anyways, now that you know what where Friday the 13th came from, are you kidding me?
To respond on your touch.
Just trying to restore the software.
You have to do that.
Well, it's running an old beta that can't be activated, so it won't show up in iTunes. So you have to put it into restore mode. Okay. I think we should be pretty legit here. Stay. Okay. So we want to write a function called merge scope that takes two inputs, one that looks like this and one that looks like this, and turns it into we quite possibly did. I think over the last couple of classes, we've seen that we've done a lot of this stuff already. And now we're starting to see uses for them. Like, who would have thought? Up. All right, so we want to take in two lists and pair them up. How do I do that? We know the lists are of the same length. Correct? So how would you rate this code? Maybe we should have a quiz. Missing Jake? Missing Dane?
Ali, Mark.
Yeah, Ali's got a decent excuse.
Last day of mercy. Or
Yeah, there's a program in Amsterdam.
why
That
not
you can
instead
work
of
for
giving
beer.
us a quiz,
Hmm?
just take down their grades instead of all of ours.
Come out with it.
All right, so how are we going to merge these two things together? For the record, you said, didn't we already do this? I'm pretty sure the function was called merge.
Yeah.
No, different one. I'm looking at it right now.
Well, rather than refer to your notes, how would we solve this now? Let's say I put something like this on the exam.
Well, do you want like a scope? Each of those scopes.
Forget about that. I want, if your input looks like this and your other input looks like this, I want you to create this list. Forget about what you're going to even use it for.
Add the cars and then call again with the footer.
Okay, what do you mean by add the cars?
That's the car. Cars. Sound like a foreign language.
Cons, the car, first list, and the second list. And then after that, just call the merge scope again on the footer of each list. But using that footer of each list.
Okay, so we're going to keep doing this as long as what's true.
The list is
As long as the computer is running.
So if null vars, when vars becomes null, won't vals also be null?
yes.
Since they're the same length? Okay, what are we going to do? If that's true, return the empty list. Otherwise, do what? You want to cons the car of vars and the car of vals. Now remember, cons only takes two parameters. And the second parameter must be a list.
So we'll list instead of cons.
Well, you could just cons.
Would you agree that I want to create a list out of the car of vars and the car of vals? I definitely want to create a list out of that, correct?
Yeah.
For instance, that would be that list,
But then next time it's gonna.
right? It's going to be that list. And what am I going to do with that list? I'm going to cons that list onto merge scope of cooter vars and cooter vals.
I hate that. I just always think you want to do that.
That make sense? So let me just define a couple things. Define vars to be that. Define vals to be that. Then I don't need this answer. And then ultimately I want to call merge scope, passing it vars and vals. And we get the list containing x5, y7, z13. That look legit? Okay. And could we say that this guy is in fact a scope? It's a list containing two lists?
Yeah.
All right. would you agree that if I am dealing with a lambda like that, the body of that lambda needs to be executed inside of the environment that has been extended with the merge scope of this and the parameters that were passed to it? Go ahead, Beaker.
So if we were to const that to the end of the scope we just put on there, that would be basically what we did the last two classes.
Well, we don't need to do that
No.
because we already have a function to add scope. This is a scope, isn't it?
Right.
That guy is a scope. We already have a function that adds a scope that takes in a scope and an environment. So I just need this guy right here, this merge scope thing, to take our parameter list from our lambda and take the cdr of, well, take all the inputs to my lambda and merge them all together. All my inputs to my app expression. Your book would say your app expression is rater and rands. It's your operator and then your operands to that. So I need to take the list of operands and my list of parameters from the lambda, merge them together with the understanding that my operands are actually expressions. They're Basel expressions. So I need to apply them in the current environment before I can merge them. Make sense? Okay, so if I'm looking at something like this, before I go up and write the code, I'm looking at a list containing a lambda expression. I call apply expression on a lambda expression. What do I do? What should I do if I'm applying a lambda expression? Here, I'll ask a challenging question. Can one apply a lambda expression?
Only if it has the input.
Well, then it's called an app expression. Lambda expressions are necessary. They are necessary. But can one actually apply a lambda expression? Or does it not stand on its own? Okay, lambdas don't stand on their own. We need the pieces of the lambda, right? So if nothing else, a lambda is a data representation for a function, correct? But a function cannot be applied until we have parameters. So a function exists on its own, but it can't be applied until we call it. And how do we call it? We call it by passing it some parameters. How do we do that in Simon? We do that with an app expression. All right, so bottom line here is that it does not make sense for us to call apply expression on a lambda. So I could call EQV the car of Basel if that guy is an app-exp. If that's true, if I'm looking at an app expression, the car of that app expression must be a what? Must be a lambda, correct? Now, do I care about the word lambda? Do I care about the lambda expression? I don't care about that, right? Car of the car, I don't care about. But what do I care about? I care about that guy. Sorry. This guy. The parameter list. Correct? So I need the parameter list from a lambda. So how do I get the parameter? If I'm looking at something that looks like this. Just steal that. For right now, I'm just going to have that return a 5 for no good reason. Just that's what it does. That guy returns a 5 just so this all compiles. I'm going to define BC8 to be the Basel code representation of Park-Simon SE8. So BC8 will equal this guy. That will be BC8 right there. Okay? Now, forget about merge scope for a second. If I'm dealing with BC8, I'll go ahead and just print it out real quick so we can see it. No, for right now, let's just get it out of there. We'll put it back in a few. Okay, so there's our BC8. Now, I want to get at this part of it. So if I'm looking at an app expression, that is, I'm looking at this, knowing full well that the first input to an app expression must be a lambda. So let's start by just getting the lambda. How do I get the lambda expression portion of my app expression? So the car of BC8 is app expression. What's the cdr of BC8? It's the list containing this list. Correct? Okay, and what's the car of that? So I can say the car of the cdr of the car. Or actually, the car of the car of the cdr. BC8. And what does that give me? It gives me our lambda expression. Right here. How do I get the parameter list of that lambda expression? Well, the car of the lambda expression is lambda expression. The cdr of that guy is a list containing a list. The car of the cdr, the car of the car of the cdr, is our parameter. So the car of the car of the cdr of whatever's returned by the car of the car of the cdr of BC8. That gets me my parameter list. That make sense? Now notice what I did. I broke it down into simple steps. I said, how do I get the lambda? That's how I got the lambda. Now once I have the lambda, if I'm looking at something that is a lambda, how do I get its parameter list? Well, I take the car of the cdr of a lambda to get its parameter list. So I could take the car of the cdr of the car of the car of the cdr of BC8. Get me the lambda expression, now get me its parameter list. And what I just extracted is what? The first parameter for our merge scope. My vars. That make sense? So for an app expression, I now have the first piece of information that I'm going to need to pass to merge scope. Where's the second piece of information come from? If I'm dealing with an app expression, the second parameters, well, the rest of the parameters are my operators. And if I'm calling this guy correctly, there must be an equivalent number of parameters in my app expression as there are values inside of my parameter list. Otherwise, you're not calling it correctly. If I have a Java method that takes 2 integers and I pass it 7 integers, not calling it correctly, right? The app expression is like me calling my Java method. The lambda expression is like me defining my Java method. If I defined it to take 2, yet I pass it 7, Java ain't happy. Same thing's true here. We can assume the person writing this is writing legal Simon code. And we can assume our Park-Simon creates legal Basel code. Therefore, we can assume, might be a weak assumption, but we can assume in our example case here that the number of parameters the lambda takes should match the inputs, the operators of the app expression. So, if this is my app expression, how do I get to my parameters? In our example here, my parameter is that guy, right? I'm passing a 5 in to this guy. So how do I get the 5 out of here? Well, we know the car of the Cutter, BC8, gets us the lambda. I don't want the lambda. I want what comes after the lambda. What will the Cutter of that guy give me? It's killing me. Oh, actually, I'm sorry. Yeah. That gives me the list containing my lit expression. Right? That gets me my list of, well, really, I can just do the car of that guy. Man, doesn't like going that deep. Jeez. So there is my list of parameters. Correct? I take it I said something funny.
It doesn't like you.
Oh.
I don't get it, Paul. Please explain.
All right. So, is this my... Now, Simon, this is a trick question. Actually, Brandon, this is a trick question, since you're obviously not paying attention. Is what I have highlighted there. Is that my second parameter to my merge scope? Here, I'll take out the BC8 here for a second, just so our output is less jumbled. We already said this is our first input. That's our list of vars. Is this our list of values? Is that the second parameter of our... Is that the second parameter of our merge scope function? I'm still asking Brandon. I said your name. I am looking at you. It's just Simon's big fat shoulders in the way.
The answer is no.
Okay. I agree. Why? Knew that was coming. Why isn't that our list of values?
No idea.
What are you going to do if I ask that on a final?
We'll know about it.
This is an easy question.
What's the question?
Oh my gosh. Okay. Remember our merge scope here? Were you paying attention when we wrote this guy? Okay. So that guy took in a list of variable names and a list of values, correct? And merged them together into a scope. We've already confirmed that this guy right here is our first parameter to merge scope. That is a list of variable names. You've just told me that this guy is not actually our second parameter to merge scope. Isn't this a list of values? And doesn't this guy take in a list of values?
It's not a list of values.
Well, you tell me. What is it?
I don't know. It kind of looks like a list of a name and a value.
Okay. What would you call this? Let's see how many weeks you haven't been paying attention. What I have highlighted there, what is that guy?
That is a list.
Okay, I agree. Let's keep going with that. What kind of list is it? I'm going to say this guy is a data structure. What kind of data structure specifically is this? Even Beaker's embarrassed for you. You know the answer, Beaker?
Yeah. It says it right there.
You got nothing for me?
No. Further than a list,
Yeah, I'd like to know what I have highlighted there.
it's a lit expression.
Okay, tell me about lit expressions.
We wrote a function for them earlier.
Okay.
A method.
Okay, what is a lit expression?
Oh, now you see the method.
Skippy?
You scroll up, or do you not have what?
You don't even need me
Yeah.
to scroll up. You don't need me to scroll up. We've been talking about this for weeks. Beaker, what is it?
That is a list of a list of five.
Okay,
Literal expression.
it's a who?
Literal.
Literal expression. Where did literal expression come from? Go ahead.
Numbers. It's from the code.
Yeah.
What do you mean?
What language is this in?
Basil.
Bazel. This is Bazel code. This is a list, sure, but what is it actually? It's a literal expression in Bazel code. So this is a list of Bazel code expressions. What does merge scope take? It takes a list of values. How do I turn a list of Bazel code expressions into a list of values? What does unparse do? That'll turn it back into assignment.
Well, it's just literal expressions.
In this case, it's a literal expression. Could it also be a let? This could be any. This is a list of Bazel expressions. We just happen to be dealing with the most simplistic one. How do I turn this particular Bazel expression into its value, which should boil down to a 5? Call apply expression. And I need to call apply expression by passing it an environment. Does that make sense? Well, empty environment would probably be our starting point, right? But the reality is whenever I hit my app expression, I've been passing around an environment that's going to be my current governing environment. But if I'm just working with this guy right here, do I call apply expression, exp, on this guy, as well as empty env? Is that what I would do? Would I call apply expression on this? It takes in two. It takes in a Basel expression, takes in Basel code, and it takes in an environment. That's what apply expression takes. Well, is this whole thing Basel code? Or is just this Basel code? Just that. It's Basel code. So the legal thing I could do here is I could pass it the car of that guy, and it would work in this particular case, correct? Oh, was it EXPR?
Yeah.
Oh, empty env is not a function. It's just the name of something. There we go. And that gets us our 5. Is that the input we want? No, we need a list. Well, hold on. What happens? I'm going to throw another curveball here. Let's go up. We need to change BC8 a little bit. So let's take in an X and a Y and a 5 and a 7. So there's my parameter list, X, Y. And let's go ahead and let's call, let's stop calling apply expression for a second. There's our list of 2 lit expressions, our operators. That's a list of Basel expressions, correct? But now I don't just have one of them, so I can't just hard code and say, give me the car. How do I apply expression to every element in that list? Map. But wait a minute. Why can't I use map? I can almost use map. Map only allows us to do lambdas that take 1 parameter. So I actually will need to write a function, a helper function. So I'm going to need to write a helper function called map apply expr, which takes in a what? Well, that is a lambda that takes in 2 parameters. A list of Basel lobsils. List of Basels. There. A list of Basels as well as an environment. Okay? So what's this guy going to do? It's going to take in a list of Basel expressions like we have right here. That's the input of that guy. As well as a current environment that they should all be applied in. And it should apply expression on each of these guys individually. Given this environment, boiling down to a single list. So the output of this guy for this would be 5, 7. That's what it should boil down to. The list containing 5 and 7. That's what we need our our map apply expression to do. Well, same pattern that we've been doing all along. If null Basels, if I'm out of Basel expressions, boil down to empty list. Otherwise, do what? Otherwise, cons, whatever's returned by apply expression on the car of Basels and my environment, onto whatever's returned by map, apply expression on the cooter of Basels in the same environment. So now what I can do is I can say map apply expression onto my list of basals as well as empty env that will call this function, and I'll get the list containing 5 and 7. Now, important thing to consider here, Coleslaw was right by saying map is the right solution for this. The problem is that the map function for scheme isn't powerful enough to do what we needed it to do. Map allows us to take a lambda that takes a single parameter and apply it to every element of a list. It just so happens that our apply expression takes 2 parameters. Therefore, we had to create our own map function. Does that make sense? That way we can use both parameters. All right, next trick question. Brandon, is this the correct input for the second parameter of our merge scope? I have highlighted here.
Yes.
Confident? Pretty confident? I think. You know the question I asked?
Yes. Is that the correct input?
That is the correct input?
Yes.
Okay. So, I could call merge scope, passing it. Well, here. Let's do define vars to be this guy. And let's do define vals. Yeah, I'll undefine them. To be this guy. Okay. Then we can call merge scope on vars and vals. And that gets us our list containing x5 and y7. So these are all the tools that we need in order to build our environment with our app expression, correct? All right, well, let's go into our am I dealing with an app expression? EQV car basal app exp. If that's true, what am I going to do? Well, I'm going to create a let. We want to match it up to what we did below. So I'm going to say let something. What's that something? Well, I need my parameter list for my let. And what's my parameter list for my let going to be? We're going to have something called vars. And what's vars going to be equal to? Vars is going to be equal to this guy of Basel. What else are we going to have? We're also going to have vals. And what's vals going to be equal to? Vals is going to be equal to map apply expression. I'm just going to steal most of this. And we're going to have to move apply expression view. Actually, let me just do that now. Let me cut these and put them right before apply. So vals is going to be equal to this guy from Basel, and not the empty environment, but the environment we've been currently passing around. Correct? So that's the environment for my let. And what am I going to do inside of that environment? I know the car. I mean, so bottom line right now, let's just have CR code merged in here. So I'm going to call merge scope on vars and vals. That's what I'll do in there for right now. We're ultimately going to need a little more than that, but so I'll do that. That's what it'll just boil down to. Okay, we can get rid of this code here. And we'll call apply. Let me actually get rid of this line so our false goes away. EXPR on BC8 with our empty environment. And what is it? What did it ultimately give us? It gave us our scope. Correct? So it gave us exactly what we were getting before, but now it's filtering through our apply expression with our let environment, and here's our merge scope. So merge scope produces for us a scope. What do we want to do with that scope? Go ahead.
Apply it to the actual function within the lambda.
Almost. If I have a scope, what do I do with scopes in terms of our current environment? I need to add it. I need to add this scope to my running environment because I have a new scope. I have a more local scope now, right? So I'm going to call add scope, passing it my new scope, and passing it my current environment, current version of my environment, right? Okay. So now I have a new environment. That's what add scope produces, doesn't it? And here we can see the output of that. So there's my brand new environment. It's a list containing exactly one scope because I'm only having one function here, right? So there's my new environment. I went from the empty environment to an environment containing one scope, which is my scope that we just built. The x is 5, y is 7. All right, so now I have a new environment. What do I do with environments? Well, I can apply an expression in an environment, can't I? I want to get the body of the lambda. Well, let's go back to the drawing board here. If SE8 is my Basel code, that is an app expression, right? BC8 rather is my Basel code, that's an app expression. So I'll say BC8 here. The body of this guy is a what? Here's my lambda. The body is my math expression right here. Does this make sense? I need to get that because I want to apply expression on the body of my lambda. That's my Basel code using the environment that I just built. We got 25, right? Oh, this is going to be awesome. It's like perfect timing to finish our language. Sick. It's just like course complete. All right, so I need to get at that part of it. Well, how do I get... We already know we can get the car of the cooter of BC8. That will get us our lambda, right? There's our lambda. So if I have that, the car of that is this guy. The car of the cooter of that is this guy. So I want the car of the cooter. Car of the cooter of that guy. What does that give me? Ruh-roh. car of that guy. Oh. The coder of that guy gives me this. The car of that is that. The car of the coder of that. CADDR.
Would it be CD? ADR?
Well, CDDR. Well, let me just look at it again here. All right, so this is a list containing a list. Oh, I need the car of that. That gives me, it's because of how we did our expressions. It contains a list as the operators. So now we have the list whose first element is our parameters and whose second element is our math expression. So now I need the car of the coder of that guy. It's correct. I just need to do it as a second. And there's my math expression. Does that make sense? So that allows me to extract the math expression. And it's that guy that I want to apply with the new environment I just built. So let me steal this here. So I want to call apply expr on, just kick it down a line here. The body, that's the body right there, and our new scope. There. And if I'm doing this on BC8, which is off of SE8, if I have a lambda that takes two parameters, and let's just say it adds the two parameters together, 7 plus 5 should be 12. There's our 12. So we just added to our language the ability to apply an app expression. That is a lambda that has a body to it to a number of parameters. And we can see how powerful we can get with this now. Hold on. Yeah, it's user error again, I promise. Oh. There we go. There's our 120.
Should have made it yellow shoot to give the equal amount of inputs and spaces.
That make sense? So now we finish our class, 1 minute to spare, with a functional language called Simon that parses into an intermediate language called Bazel that supports math expressions as well as functions and local environments. So we just built a programming language. Your exam, what day is the exam? Thursday at 10:10? 1:10?
Yeah, 110 on Thursday.
Yep, Thursday 1:10.
You got all morning stuff.
7:35.
All right, so in any case, the exam, I'm going to design it to take about an hour. But you'll have the full 2 hours to work on it, so it shouldn't be a time crunch thing. It will be a lot of scheme programming. Okay? A lot of it, though, will be simple functions, like write up. I wouldn't just say write up. I would say, given this input and this input, create a output, create a function that creates this output, that kind of thing. Little puzzle type things. Okay? So I would say it's going to be at least 70% programming. The other 30% will talk about language concepts. Make sense? You can use your notes.
I'm gonna write every program in Steam from now.
Okay? You can use your notes. You can, if your notes are on your laptop, that's fine. You can use your laptop. You cannot use Dr. Racket. So don't cheat. No Dr. Racket, no Google. Just, you know, if you
Use Yahoo, guys.
yeah, if all your notes are inside of Dr. Racket, I'm fine with you using that as long as you don't press run. Okay? I don't want you testing your code is the point. Okay? On a handwritten test, you expect the code to be a little bit less than precise. Go ahead.
I use the app I use, it can't run. It literally can't run.
Yeah, as long as you can as long as you look at yourself in the mirror and you say I didn't cheat, I'm fine with it. All right? I mean, you're only screwing yourself over. All right? Make sense? Questions, comments, concerns, bribes? Go ahead.
Can you scroll?
Nope.
Can you post this?
Delete it all.
Are you taking bacon bribes?
You want me to post the whole thing?
I just wanted to look at the.
Well, let me copy the whole thing. I'll post it here in a second. Where do you want? Apply?
Yeah, the variable we just wrote in the box.
This guy? Stop the recording. Okay, we're done. I'll see everybody next week.